My speakers are dusty these days, so I put them to good use in harmonic experiments which need amplifiers like the one next to the quarter. I use an integrated circuit like the LM386 since designing an amplifier from scratch that's actually louder than the audio source is not easy. So in this video, I will go over the process behind making this amp, its performance, and its features. The schematic has 8 components including the speaker and it's in the description. After testing minimal LM386 amplifier circuits was when I started to optimize the design for best sound, albeit high gain. In my experience, the biggest difference in sound quality came from selecting a capacitor on pin 3 with a 10 nanofarad ceramic capacitor being the best choice for hearing words clearly while allowing some bass through as well. Here's some documentation that led up to this verdict. So as you've probably heard, the low tones don't dampen the high ones in the 10 nanofarad capacitor unlike the 100 microfarad capacitor. If your input capacitance is too low, as would be the case with some small ceramic capacitors, the output will be rather quiet and the bass will be quite suppressed. If your input capacitance is too high, as would be the case with at least a 1 microfarad capacitor, human speech on the output would be unintelligible from all the bass drowning it out. Someone would need a good microphone to be understood through a 100 microfarad capacitor, and I've tested this specific amp setup with lots of podcasts. Ceramic capacitors in the nanofarad range will allow you to understand someone even if they have poor audio quality. So now I'm going to simulate an instrument by playing single frequencies through the amplifier. In this case, I am using 40 Hz, which is the open E string on the bass. Now, I am simulating the open E string on the guitar, which is 80 Hz. I like this sound the best if you ask me, but let's test other octaves as well. Anyways, I really approve of the design. It sounds great. Despite the amplifier being so small, I managed to add an LED audio chaser onto it completely by accident. Originally, I put a resistor and an LED between power and ground, thinking I was just going to have a power indicator, but to my delight, I noticed the LED flickered with the audio. I think the reason for this is the amplifier consumes more current than the LED when the signal gain is high enough, so there is a flux in current around the LED. Thus, the more change in volume, the more visible the LED flickers. If the speaker is disconnected, however, the LED brightens and consumes the current as the only load, denoting the power as originally intended. This LED chaser yields best results when the audio is someone with a deep voice speaking in contrast to a quiet background, which leads me to believe that the low tones are more clearly shown by the LED due to their longer cycle periods. Next, I'm going to demonstrate the amplifier with human speech as the audio input, with the source carefully selected for clear voices and quiet backgrounds.
How much does, you talk about Medicare Advantage, and Medicare Advantage takes up about, 50% now of all the people that's on either Medicare or Medicare Advantage. Now, if we got rid of Medicare...
In conclusion, this project yielded me a useful tool for harmonic experiments and more lessons than I thought I'd learn. Although I did not specifically mention C1, C2, C4, and C5, they are integral to the sound quality and volume, so I do not recommend any modifications for now. If you liked the video and you're interested in more of these projects, leave a like, subscribe, and stay tuned for a video on my homemade sound system.